It's so good to see everyone. I'm so glad that you could join us again for Spring into STEM. Spring into STEM. I'm Hannah with Science Club for Girls, and that was Mr. Music with your theme song. Awesome. Hey, Mr. Music, guess what we're talking about today? That's right, music! Sound. We're going to explore the science of sound today. So, Mr. Music, don't go too far because I feel like we might need your help. I think that means yes, he'll stick around. All right. Now, before we begin, let's say hello to a few people. I see Juliana's here. I see Sarah's here. Claire, Bonnie. It's so good to see everyone. It always makes my week to see you guys tune into these shows. All right, so before we jump into sound, let's talk a little bit about last week. Last week, we did such cool experiments. We did some explosive experiments by creating volcanic slime and an volcano. Now, a few of you were super scientist rock stars and did the experiments at home. I want to shout a few of you out. So let's take a look. The first scientist I want to shout out is Caroline. Caroline is 6 years old and she made her very own volcano. Great job, Caroline. I especially love that you wore your extra special safety goggles. Nice job. The next scientist I want to shout out is Sarah. Sarah is in 3rd grade and she also made an volcano. I love it. Nice work, Sarah. Now, the last person I want to shout out is a little bit unusual. I got a very strange email from a dog who was also doing our experiments. Let's take a look. Well, at least he was a curious dog. I'm very curious to hear how that egg experiment turned out. He definitely gave it a little shake. Nice job, Teddy the dog. Remember, if any of you want to send in your science experiments, I would love to show them on the show. You can send it to the email at the bottom of the screen, or just send us a message in Facebook, and we will be sure to give you a special shout out on next week's episode. Way to go, though, Caroline and Sarah. Okay, time to move on. Oh, I forgot someone else I wanted to ask. Mr. Marbles, did you happen to see any chemical reactions happening this week?
And this bird you cannot change. Oh, no, I can't change it.
Dr. Marbles? What's going on?
Hey, Hannah.
Hi, Dr. Marbles. What were you doing?
I was listening to my favorite song, Free Bird.
Of course you were. Now, normally I'd kind of be upset with you, but because this week's theme is sound, I'll let it slide this one time, okay?
You got it. I am so psyched for today, Hannah.
I am too. Now, before we jump in and I ask you your question, I wanted to clarify your name thing says Dr. Marbles. We decided that because you have a master's in science, you got your PhD, you got a medical degree. I think you have a degree for dentistry. I think you have like an anthropology. I mean, you got a lot of degrees. We figured it makes sense to call you doctor. So does that sound okay?
As you wish.
Of course. Now,
very nice of you guys.
Oh, we try. I have a question for you.
Yeah.
Did you happen to see or experience any chemical reactions in the last week?
You know what? I did.
Oh my God, tell us about it.
So here I was, I went out for a ride. My car was down, kind of getting low on gas. I went ahead and filled up the gas.
Okay.
And of course, drove away. And I had just done the Science Club for Girls, and we had just done our episode on chemical reactions.
Right.
So I was primed. I was thinking about it. It turns out gasoline with a little spark can cause energy, combustion, and it makes the engine run.
Wow.
Yeah. So you add a little heat, a little bit of oxygen, like in the air we breathe, and some fuel. That's the gas. And you get energy. And that's how the car was running.
That's awesome. So a chemical reaction happened in your car?
Yeah, luckily I had a chemical reaction in my car because I had to get some eggs.
That's true. You do love your eggs. Cool. Well, I also experienced a chemical reaction this week.
Oh, what?
It was Mother's Day on Sunday.
Yeah.
And so I made my mom some lemon bars.
Nice.
And I observed in my science journal. Let me grab it really quick to show you.
Okay. If you remember, we were talking about the stomach.
Right.
And that's when the lemon bars go in the stomach. There's a chemical reaction that goes on in the stomach that allows you to digest them and get all the good nutrients from them.
That's
but what
right.
did you find when you were baking them?
Well, so I actually drew a picture of what the bars looked like before I put them in the oven.
Nice.
And after I put them in the oven, and they looked really different. Like the texture was so different. At first, it was really gooey and slimy.
Yeah.
And then after they came out of the oven, they were solid. So I figured because there was some kind of change in texture, and I also did see a few bubbles, that a chemical reaction must have occurred when I was baking my lemon bars.
Most definitely. One of my favorite reactions is baking.
Mine too. Mine too.
Oh, those look delicious.
It's so tasty.
Yeah.
Yeah. So, yeah.
Go ahead.
No, I was just gonna say that was the chemical reaction that I experienced this week. So just be sure to keep your eye out for those because they're everywhere.
Hey, Hannah.
Yeah.
If you ever want to do another kind of baking chemical reaction, let me know. I'd be happy to help.
Oh, that would be great. I think in the future we're gonna do some kitchen science, so that would be perfect.
Awesome.
Cool. All right, Mr. Marbles, I'm gonna say goodbye until we start our experiments. Okay?
Terrific. See you soon.
Awesome. See you soon. All right. Now it's journal time. So before we jump into our experiment, let's set up our journals. Here's what you need for your journal today. Remember, if you don't have a journal already, just go ahead and grab some paper and a pen or a marker or whatever you want. Today's date is May 13th, and our science topic is science of sound. Cool. This will be really helpful today because we're going to be doing lots of observation, especially with our ears when we hear. All right, time to jump into the science. So as I was saying, because I've been home so much, I've been listening to a lot of music and podcasts and movies and TV shows, and that got me thinking about sound. How does sound work? How can something make sound and that gets into our ears and then we interpret that sound? So in today's experiments, that's what we're going to explore. Okay, for our first experiment, you're going to need some wax paper. If you don't have wax paper, you can use tin foil, you can use plastic wrap, or you can just use regular paper. A bowl, doesn't matter what kind of bowl, I'm using a metal bowl. A rubber band. If you don't have a rubber band, you can use tape, works the same. You're also gonna want some rice. You can also use salt, sugar, or beans. Any of those work. And the last thing you'll need is a speaker. Make sure your speaker or your phone actually, you could use a phone too. Just something to play music. Okay, now we're ready to start. The first thing I'm gonna do is I'm gonna put my speaker into my bowl. I'm gonna make sure it's on first. There we go. Next, I'm gonna put my saran wrap or my wax paper over my bowl like so. Now, in order to make sure that it's nice and tight, I'm gonna put a rubber band around my bowl. Make sure you tighten it up so it's nice and tight. This reminds me a little bit of like a drum. Then you want to put your rice or sugar or salt on top of your bowl. I put some food coloring in my rice just to make it a little bit easier to see. Spread it out a little bit just so each piece of rice gets its own little space. And there we go. All right, now for the fun part. I'm gonna turn my music on. Now, before I turn my music on, I want to know, what do you think is gonna happen to the rice when I start my music? Let's make a hypothesis. Dr. Marbles, I'm curious what you think. What do you think is gonna happen to the rice when I turn my music on? Let's bring you back in and find out.
We are the champions, my friend.
Dr. Marbles.
Oh, hey.
You gotta be ready to come in.
Oh, sorry. I was just listening to my tune.
Oh, gosh. All right. So, question for you.
Yep.
I want you to make a hypothesis.
Okay.
What do you think will happen when I turn my music on? What do you think is going to happen to the rice?
I think they're going to vibrate.
Why?
They're going to bounce up and down.
Why?
I'll tell you why.
Okay.
I was at a rock concert recently. I was listening to Freebird, my favorite song.
Of course.
As I was listening to it and they were playing really loud, I started vibrating. Like that. Just like this crazy vibration. I felt it in my body.
That's insane.
So I think when that speaker starts to play, those rice are going to jump.
Oh my gosh. Well, I actually just saw that Sarah and Claire also think the same thing's going to happen.
Oh, excellent.
Cool. Should we take a look?
Let's watch.
All right. I'm going to zoom the camera in just so you guys can see. Here we go.
Here they go.
I like that song.
Me too.
So what happened?
They jumped.
They did. It was pretty cool. Did it remind you of like the rock concert that you were at?
Totally did. This is what the rice were doing, and this is what I was doing.
Exactly. Nice job, Sarah and Claire, making the same hypothesis.
Oh, excellent.
So let's talk a little bit about exactly what's going on here, okay? So what's happening is that this is allowing us to actually see sound. Normally we can just hear sound, but this is allowing us to see what is causing the sound. So all sound is produced by something called vibrations. Vibrations. Now, what is a vibration? Well, a vibration is when something moves back and forth so quickly. Usually it's too quickly to actually see with our eyes, but sometimes you can see it. So for example, here I have just my own little kind of guitar. If I pluck the rubber band, look extra carefully, you can kind of see it vibrate. Now, what happens when these things vibrate is they actually cause the molecules around it to move as well. You see, in the air, there are so many teeny tiny particles, smaller than this piece of rice, that we call molecules. And when those molecules are hit by a vibrating object, they also move and bump into the molecules next to them. Let me show you something that might actually help. Here's an image that shows what's happening to those molecules. The gray bar right here is kind of like our rubber band. When that rubber band moves, it causes the molecules around it to move and bump into the ones next to it. This sends a wave of energy that we call a sound wave all the way to our ear. Pretty cool. Now we'll talk a little bit more about what happens when we get in the ear a little bit later. I want to show you one other example to show how vibrations cause sound. This is called a tuning fork. Now, when you hit a tuning fork, it makes a sound like this. And if you look really carefully, you can actually see the tuning fork vibrate. Now, if you can't see it vibrate, I can show you that it's vibrating with a bowl of water. Watch this. I'm going to hit the tuning fork and then place it in the water and observe what happens. Ooh, let's try it one more time. Did you see that? The water started to splash everywhere. That's because those vibrations were causing the water molecules to start to move and eventually splash. Pretty cool. Now, let's go back to our experiment. What happened in our experiment is actually that the speaker was forming vibrations. Those vibrations caused the air molecules in the bowl to start to move and eventually hit our piece of wax paper. When it hit our piece of wax paper, the wax paper also started to vibrate and eventually move our rice. Pretty cool. All right, so now what exactly happens when that sound wave hits our ear? Let's bring Dr. Marbles back to find out. Hey, Dr. Marbles.
Hey, Hannah.
So we're a little bit curious. So we've already covered that sound is produced by vibrations,
Yep.
and those vibrations cause the air molecules near it to move and eventually hit our ear.
Yep.
Now, what happens once those molecules hit our ear?
Yep. Well, you said it right. And I heard it. Well, the first part of this equation is the ear.
Okay.
One of our senses. And that's why I love we're doing sound today. You know, the other senses are sight and smell, but sound's one of my favorites, and it enters through the ear. And those vibrations that you were talking about, Hannah, they go into the ear, and then they start making their way to the eardrum.
Oh.
When you get to the eardrum, they start causing that eardrum to vibrate, just like those rice did when they were on top of the wax paper.
That's so cool.
That vibrating eardrum then sends vibrations, wait for it, to some small bones. And those bones send them to some hair cells. And the hair cells then cause the neuron, I like to call it the wires of the body, up to the brain. And you see that brain all smiley? That's because it's listening to Freebird. And that's how it works. All these little partners working together to get sound into the brain so you can hear it and enjoy it.
That's so cool. So a bunch of vibrations, a bunch of moving molecules, a bunch of neurons, and then eventually the brain?
Yep.
Cool. I love it. Well, thanks for going over that with us.
My pleasure.
Awesome. Now, for our next experiment, I'm a little bit curious. I want to know if sound can just travel through air, or could it also travel through water and a solid? For this experiment, you're going to be able to join in. So let's talk about air. We already know that sound can travel through air. If it couldn't travel through air, you wouldn't be able to hear me right now. Right now, when I speak, I'm causing those air molecules to bump, 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 and eventually hit the computer and then hit your ear. But if I was talking to you in person, it would hit your ear. Now, what about in a liquid? Now, for this, you're going to need a large bowl of water, 2 metal objects like spoons, and your ear. So for first, I'm going to place my metal objects in the water and hit them together and see if I can hear anything. Listen carefully. If you have this at home, go ahead and do it. I can still hear it. It sounds a little different than if I hit them in the air, but I can still hear them. Let me try one more thing. I'm going to hit them under the water again, but place my ear closer to the bowl. Let's see. Yep, I can still hear it. That must mean that sound can travel through water. You might know this if you've ever had an underwater tea party with a friend at a beach or a pool, and you try to say something to them. It sounds a little funny, but you can still hear something. Pretty cool. So sound can travel through air, sound can travel through water. What about a solid? For this, everyone can join in. Place your head on the table that you're watching this on and give it a knock. See what you can hear. I still hear it. Now, this is just like if someone was knocking on your door. You can hear them knock on your door, even though your door is a solid. So sound must also travel through a solid. So sound travels through solids, liquids, and gases. Pretty cool. All right, now in this last experiment, we're gonna see why some sounds sound different from others. For this, I'm gonna call on Mr. Music. Hey, Mr. Music! He's back. Now, Mr. Music, I want you to play 2 different sounds. Listen carefully. Okay, that was sound 1. Let's hear sound 2. Do sound 1 one more time. Okay, sound 2. Huh. How did those sounds sound different? How would you describe what those sounds sounded like? I think one of those sounds was a little bit lower, and one of those sounds was a little bit higher. We call that pitch. Now, let's do an experiment to find out what that means. I have 4 glasses. 1, 2, 3, and 4. Now, what's different about these glasses? Well, they have different amounts of water. In fact, this glass doesn't have any water, and this glass has a lot of water. Now, let's see what happens when I hit each of the glasses with a chopstick. What did you notice was different? Just like Mr. Music's notes, one of those notes sounded really low, and one of those notes sounded really high. What's different between the glass that sounds low and the glass that sounds a high? Well, the glass that sounds pretty low has a lot of water in it. And the glass that sounds high has no water in it. So that must mean that the more water is in the glass, the lower the pitch. And the less water in the glass, the higher the pitch. But why is that? Well, when I hit the glass, it causes it to vibrate. Remember, those vibrations produce the sound. When there's water in the glass, though, it makes those vibrations a lot slower. In fact, the sound waves that come from this glass look something like this. We call this having a low frequency or really slow vibrations. Slow vibrations, low pitch. But what about in this glass? Well, there's nothing slowing down the vibrations. So we have really fast vibrations. Something that looks like that. Fast vibrations, high pitch. Slow vibrations, low pitch. You can do this experiment at home with any type of glass. See if the liquid in the glass changes the sound, or maybe if the shape of the glass changes the sound too. I can't wait to hear more next week. All right, let's bring back Dr. Marbles to summarize what we learned today.
Hey!
Hey, Dr. Marbles.
I love that experiment with the glasses, Hannah.
It's such an easy experiment that anyone can do at home. Even just when you're sitting at a dinner table, give your glass a little tap, drink some of that water, tap it again, and see what happens.
Yep, it's a great experiment. It really shows the power of sound.
It's pretty cool. Now, we covered a lot today, but I think there's one more thing that you wanted to show us, right?
Yeah, one thing.
Okay.
Hey, you know, you've been talking a lot about sound traveling.
Mm-hmm.
I was wondering, you know, the speed of sound. I mean, it must travel at a certain speed. Well, it turns out that if you travel faster than the speed of sound,
that must be really fast.
super fast. In fact, you can't run it. You can't even sprint it. You got to get.
What about the people that run in the Olympics? Can they run faster than sound?
Nope, not fast enough.
That's crazy.
You know what you need, Hannah?
What do you need?
You got to get in a plane.
That is pretty fast.
And it turns out that Jackie Cochran was the first woman to travel faster than the speed of sound.
That's so cool. When did she do this?
She did that in 1953.
Wow. That's
and you know what ends up happening, Hannah? Maybe you can hypothesize. What happens if you travel faster than the speed of sound?
Well, if you're traveling faster than the speed of sound, then that means that you've traveled somewhere faster than sound can get there.
Yep.
So, can you not hear anything?
You hear nada.
That's crazy.
Nada. Zippo. Nothing.
Wow.
And she did that. It's pretty amazing. Turns out, because she did that, she was honored in the Aviation Hall of Fame.
Cool.
Yeah.
That's awesome.
That's where all the famous pilots go.
That's so cool.
Yeah.
Thanks for sharing that, Dr. Marbles.
Oh, you're welcome. Super cool woman.
Really cool. Now, not only do pilots use the science of sound to do things, but engineers use sound, musicians use sound. I mean, there's so many different science careers that use the knowledge of sound energy to make things and do things.
Yep.
It's really pretty cool. But hey, Miss Dr. Marbles, do you want to know something?
What?
There's one place that you actually can't hear sound. Do you know where that is?
Where?
Outer space.
Oh, yes.
Really cool. So next week, we're actually going to be talking about outer space and doing some outer space experiments. Come back for that, because that's going to be great.
Hannah, did you say next week we're talking about outer space?
Yeah, we're going to take a field trip to the moon.
What?
I know.
Cool.
I know. I'm so excited.
Me too.
Well, it was great seeing you, Dr. Marbles. I'm so happy that you could join us. You should get back to your music listening.
Will do.
Awesome.
Great seeing you, Hannah, and great seeing you guys.
Bye, Dr. Marbles.
Bye, guys.
Thanks, everyone, for joining us for another episode of Spring into STEM. For more at-home STEM activities, please check out scienceclubforgirls.org. Next week, we'll be taking a field trip to the moon, so be sure to join us for that. And if you have any pictures or videos that you'd like to send in for us to highlight next week, please send it to our website or Facebook or Instagram, actually. Any of those work. And we'll see you next week. Bye, guys.